In the late summer of 1977, humanity launched two messengers into the cosmic ocean. Not with the roar of 1,000 suns, but with the quiet determination of science. These were Voyager 1 and Voyager 2, twin spacecraft embarking on a journey that would redefine our understanding of the solar system and carry a whisper of our existence to the stars. Their mission was born from a rare celestial alignment, a once-in-176-year opportunity that would allow a spacecraft to use the gravity of one giant planet to slingshot to the next. A grand tour of the outer solar system was finally within reach. Voyager 2 launched first on August 20th, 1977, followed by Voyager 1 16 days later on a faster, shorter trajectory. Their primary targets were Jupiter and Saturn. As Voyager 1 approached the colossal gas giant Jupiter in 1979, it sent back images that stunned the world. We saw a planet not as a serene, banded orb, but as a maelstrom of violent storms, swirling clouds, and the iconic Great Red Spot, revealed to be an ancient, hurricane-like storm larger than Earth itself. But perhaps the most breathtaking discoveries came from Jupiter's moons. Voyager 1 gave us our first close-up look at Io, a world torn apart by Jupiter's immense gravity. Instead of a cratered, frozen surface, we found a hellscape of active volcanoes spewing sulfur hundreds of kilometers into space. This was the first time active volcanism had ever been seen anywhere other than Earth. Then there was Europa, a world wrapped in a smooth, icy shell crisscrossed by mysterious lines. The images hinted at a tantalizing possibility, a vast, liquid water ocean hidden beneath the ice, potentially a habitat for life. Ganymede and Callisto, too, were revealed as complex worlds in their own right. After its triumphant encounter with Jupiter, Voyager 1 raced on towards Saturn, the ring jewel of our solar system. In 1980, it flew past the planet, revealing the intricate, almost unbelievable structure of its rings. They weren't solid bands, but were composed of thousands of individual ringlets, braided and kinked by the gravitational dance of tiny shepherd moons. Voyager 1 also performed a close flyby of Saturn's largest moon, Titan. Its thick, hazy orange atmosphere had always hidden its surface, and scientists were desperate for a glimpse. While the cameras couldn't pierce the smog, the probe's instruments confirmed that Titan's atmosphere was mostly nitrogen, like Earth's, but with a significant amount of methane, creating a complex organic chemistry. This tantalizing world, with its thick atmosphere and potential for liquid methane lakes, became a prime target for future missions. This close flyby of Titan, however, came at a cost. To get the best data, Voyager 1's trajectory was altered, sending it soaring up and out of the plane of the solar system, ending its tour of the planets. Its grand tour was over, but a new, lonelier mission was just beginning, the journey to interstellar space. Meanwhile, its twin Voyager 2 continued the planetary marathon. Having also studied Jupiter and Saturn, it set its sights on the distant ice giants Uranus and Neptune. In 1986, Voyager 2 became the first and only spacecraft to visit Uranus. It arrived to find a pale blue-green world, tipped over on its side, likely from a colossal impact eons ago. Its magnetic field was bizarrely off-kilter, and its faint, dark rings were unlike any seen before. Its moons were equally strange, particularly Miranda, a Frankenstein's monster of a world that looked like it had been shattered and haphazardly reassembled, with vast canyons and bizarre chevron-shaped features. 3 years later, in 1989, Voyager 2 reached its final planetary destination, Neptune. This deep blue world was far from the quiet, cold planet many expected. Instead, Voyager 2 discovered the Great Dark Spot, a massive storm system similar to Jupiter's Great Red Spot, and the fastest winds ever recorded in the solar system, raging at over 2,000 kilometers per hour. It also discovered faint rings and a collection of new moons. The most fascinating of these was Triton, a large moon orbiting Neptune backwards. Its surface was a cryogenic wonderland, with vast plains of frozen nitrogen and geysers erupting plumes of dark material into its thin atmosphere. After this final, spectacular encounter, Voyager 2's trajectory also sent it hurtling south, away from the Sun and towards the unknown. The grand tour was complete. The two Voyagers had rewritten the textbooks. They transformed the planets from distant points of light into dynamic, complex worlds. They showed us volcanic moons, subsurface oceans, bizarre rings, and supersonic winds. Their journey gave us a new perspective on our own solar system, revealing it to be far more diverse and active than we had ever imagined. But their mission was far from over. As they coasted silently through the void, their instruments continued to measure the environment around them. They were heading for a boundary that no human-made object had ever crossed, the edge of the sun's influence, the heliopause. This is the invisible bubble blown by the solar wind, separating our solar system from the vast expanse of interstellar space. On Valentine's Day 1990, at the request of the late astronomer Carl Sagan, Voyager 1 turned its camera around one last time to take a final family portrait of the solar system from a distance of 6 billion kilometers. In that iconic image, our Earth is just a tiny speck, a pale blue dot suspended in a sunbeam. It's a humbling photo that puts our entire existence into cosmic perspective. For decades, the Voyagers continued their journey outward. Their power sources, fueled by the decay of plutonium, slowly waned, forcing engineers to make difficult decisions about which instruments to shut down to conserve energy. Then, in 2012, the data from Voyager 1 changed. After traveling for 35 years, it had finally crossed the heliopause. The probe's sensors detected a sharp drop in solar particles and a dramatic increase in galactic cosmic rays. It was official. Voyager 1 had entered interstellar space. It was now swimming in the sea of particles and plasma that fills the gulf between the stars. Voyager 2 followed suit, crossing the boundary in 2018. Today, both spacecraft continue to send back unprecedented data from this unexplored region. They are the farthest human-made objects, traveling farther and faster than anything that has come before them. They are our first emissaries to the galaxy. Attached to each spacecraft is a message, a time capsule intended for any intelligent life that might one day find them. It's the Golden Record, a gold-plated copper disc containing sounds and images selected to portray the diversity of life and culture on Earth. It includes greetings in 55 languages, music from different eras and cultures from Bach and Beethoven to Chuck Berry, and the sounds of nature, like wind, rain, and the calls of animals. It's a greeting card to the cosmos, a testament to who we were and what we hope to be. The Voyager probes are now more than 24 billion kilometers from home. Their signals, traveling at the speed of light, take more than 22 hours to reach us. They are expected to continue transmitting data until around 2025, when their power finally runs out. After that, they will go silent. But their journey will not end. They will continue to drift through the Milky Way for millions, perhaps billions, of years, silent ambassadors carrying our story into the vastness of eternity. The saga of Voyager is a testament to human curiosity, ingenuity, and our unyielding desire to explore. It's a story of a journey that started in our backyard and ended in the stars. Thanks for watching, and don't forget to subscribe for more journeys into the cosmos.